Well, good morning and welcome to Nani Notes. Hey, today's topic, well, it's actually scientific notation, but I don't see how we can talk about that without just mentioning the basics, our numbering system. So a little nod here to Algebra for helping bring us our numbering system and that thing we call algebra. So, well, let's get to it, and we'll go right here. All right, now I had a little worksheet and a little follow along, and I'll try to put this on my site so you can download it if you're a teacher. And gosh, I remember teaching this in pre-algebra, our numbering system. Well, what do we call it? Well, we call it the Hindu-Arabic numeral system. Well, I know some people debate that, but well, that's what I call it. Who brought it to us first? Well, let's see. Al-Khwarizmi helped us out with that. But, well, I guess we'll have to do our own research there. Our numbering system is a positional numbering system, and we have 10 digits. And they operate on a base 10 system. Yeah, you've heard that before. But what does it mean? Well, first, maybe we should look at a contrasting system. Here's one we all know, the Roman numerals. Well, they are not positional. That is a grouping system. And no better example of that than you get in the NFL. And we know, the L, the V, and the I, and we group them together. And just like we group the years together. 2x is 20. Oh, that makes sense. Now, the Greek numbering system, here's one that's a little bit different, maybe you haven't seen. That is a ciphered system. And what does that mean? Well, let's take this case. If these are the Greek ciphers, and let's compare the number 12 to the number 21. Well, if the 1 is alpha, and the 2 is beta, instead of just reversing the letters, we have two different symbols. If the K, kappa, is 20, and iota, oh, sorry, I messed that up. Sorry, 21, that would be kappa alpha, iota beta. Not even paying attention to my own system there. So here, 4 different characters to represent these 2 different numbers. That would be tricky. Okay, that's a little background. Now let's, oh my gosh, let's talk about place values. Come on, you did this back in grade school. Well, maybe you didn't do it enough because my students in Algebra 1 weren't getting it. We all look at those little boxes. We're going to use those to represent positions. And we're just going to put something there. We're going to put down an anchor, and we are going to call that we'll call that the decimal point, right? And we know to the left of the decimal point is the ones place, and then the tens place, and then the hundreds place. We always say dreads, thousands, 10,000s, 100,000s, and the millions, which is to be a little different than saying the tenths with a th, hundredths, thousandths, 10,000ths, 100,000ths, and the millionths place. Wow. You guys remember writing all that out? I sure hope so. Because really, what we're doing, well, we're going to make some examples. We're going to take this number and we're going to write it in standard form. This is called expanded form. Well, hang on. What is all these decimals? Or what are all these numbers here, these exponents? Well, these place values, we set a base 10, right? So let's just say that each of these corresponds. The ones is 10 to the 0 power. You remember any non-zero number to the 0 power is 1, 10 to the first power, 10 to the second power, etc. On the other side of the decimal point, the negative exponents. So, shall we write this in scientific notation or in standard form? Sure. I mean, we could just do it this way. Say, look, this 7 goes in this box. The 10 to the 5th power is here. Do you see any 10 to the 4ths? I do not. 10 to the 3rd. I only see one of them. I see a 6 in the 10 squared. I see a 9 here. 10 to the 0 power. I see nothing there. I see a number there. And I see a number there. Now, because we have a positional system, we'll use those zeros to hold down those other places, and we could just write this number just like this: 7, 3, 0 for the 10 to the 4th or the 10,000ths place, the 1, the 6. We see no 10 to the 1st or 10s, and we see a 9 and our decimal point 0, 4, 8. Hey, that's pretty cool. And one other thing we like to do, we like to, in our groups, every 3 like that. So our millions stand out there. Our 10 to the 6th, 7 times 10 to the 6th, 7 million. And there's our number. Hey, that's kind of cool. So look how this all works together. We learn exponents, we learn our place values. So, let's write this in scientific notation. Well, let's go ahead and write that number down. I'm just going to write the digits. I'm just going to write them like this. Or do I already have them written? I forgot how I have this set up. Well, let's just write them out. So we've got 7, 3, 0, 1, 6, 0, 9, 0, 4, 8. Now, if I'm looking at this and I want to write this number in scientific notation, and I'm going to start with my decimal point right here. You guys remember how this goes? 1, 2, 3, 4, 5, 6. I'm going to move that decimal point 6 places, which is another way of saying I'm multiplying by 10 to the 6th power. Oh, don't worry, we'll do some more practice in the subsequent pages. Hey, that's kind of fun. Let's do something else here. Now, let's write this in expanded form. Pick a different number. And shall we? So I'm looking at it this way. I'll just use C. I'm going to take each of these digits. I'm going to take the 7, and I'm going to say, what place value is it? That's 7. Well, I'm losing my track up here. 10 to the 3rd power. That's the thousands place. I have 7,000. I've got a digit 8, and that's in the hundreds place. That's squared. 10 squared is 100. I've got nothing in the tens place, so I don't need to write it. I'm going to put down the 9, and that's in the ones place. I've got a 1. Well, I don't need to put 1. Let's suppose I did put that there. And that's going to be 10 to the negative 1 power, negative 1. But see, it's just not even necessary. I could just take that off. And then I've got 2, and that would be in the negative 2 power, the hundredths place, and the 3, etc., in the negative 3 power. That's expanded form. Oh, scientific notation, oh heck, we'll be doing enough of those on the next pages. All right, so in your McDougal Littel textbook, you have these exercises. Well, this is really fun. Let's write these numbers in scientific notation. So in each case, we know that we're going to rewrite. We're going to have one non-zero digit in front of the decimal place. So in this one, 8.5, do we have to move it at all? Heck no, it's right there. It stays there. So that's just 8.5 times 1 times 10 to the 0 power. Okay, how about this one? 0.72. Now, I'm moving this one to the right. So I am going to say times 10 to the negative 1 power. Oops, wrong character. Bad teacher. Negative 1. By contrast here, I am going to move it this way. 8.24 times 10 to the first power. Now let's just stop for a minute and say, wait a minute, does this make sense? Sure, 8.2 or 82 is, well, 8.2 times 10. That makes sense. Ask yourself if it makes sense. What is this? We're going to move this 1, 2, 3. That's 5 times 10 to the negative 3. The negative third power. So that I could read that if I was remembering my chart. If I was remembering my place values, I would just read that as 5 thousandths with that TH. Love that TH. Okay. How about this one? 3, 6. In slang terms, I would call that 72 million. But scientific notation, I can only have one number or one non-zero digit in front of that decimal point. So I moved it over 7 places. Easy squeezy. How about here? 1, 2, 3 to the negative. I keep hitting the wrong character. Negative third power. We doing good? Okay, well, let's keep this momentum rolling. All right. Oh, heck, we've done a bunch of these, but all right, we'll just jump around a little bit here. How much are we moving the decimal place here? Again, this is a whole number, 3, 6. We're moving it, that's a million times, or that's the millions place. We could see 6 decimal places. How about 10 here? 3, 4, 5. 5 to the right. We'll go negative 5. Oh, messed that up. This is pretty, you're getting pretty good at this. These commas help us out. 3, 6, 9. Heck, we know that that's going to end up being a 9 because we're going to move that decimal point. 3, 6, 9. Right? I should leave some of them for you guys, but well, I'm having too much fun. 1, 2, 3, 5, 6 to the right. Negative 6. Is this all coming back? You guys learned this a while ago, right? All right, I'll leave you with these last 2. I think you guys got the pattern down. And were the other ones any different in this textbook? I can't remember. Oh, yeah. Okay. Write it in standard form. I got a bunch of zeros here because we're going to need them. 2.6 times 10 to the third power. And again, we're moving that decimal point 3 places. Well, you move it, that's 1. Well, when you move it again, well, you need a placeholder. And then you move it again, you need another placeholder. So that number is going to look like that. That's 2.6 times 10 to the third. 2.6 thousandths. We would often say 2600, but it's 2.6 thousands in our scientific notation. Oh my gosh, you're going to have to add, or you're going to have to attach a bunch of zeros here, because 7.5 times 10 to the 7th, that's, oops, I missed it. How did I make this? I can't remember. So I'm going to try to grab that decimal point. Dang, I made that too hard. So that's 3, and just have to keep going. 4, 5, 6, 7, and there you go. Okay, makes sense. And I think you guys got this one right. We're going to move the decimal point here. We got 1, 1, 1. Well, if I move this 1, 2 places, that's all I got. How about this one? And we'll stop on this one, let you guys save something for you. The old 303. 1, 2, 3, 4 places. I'm going to move it 4 places. I'm going to need a couple placeholders and our 0, because we have a positional numbering system. So we need those placeholders, that 0. All right, how about if we go, I think the next one's, oh yeah, they go the other way. Get you ready for chemistry. Your chemistry teacher wants to know that you can understand scientific notation. 6.1 times 10 to the negative third. So I'm looking at the decimal point there. I'm going to move it once. Now watch, you got to remember that. You got to count that as one place, right? Then you're going to need some placeholders. And then you're going to move it again. And then again, 0.0061. Yikes. Well, I'm getting too stymied with this. I'm going to skip down to this one a little bit easier, and I'm going to end here. So again, 2.23 times 10 to the negative 6. That's 1. And you're going to need a whole bunch of these zeros. 2, 3, 4, 5, 6. And it's going to end up looking like that. You got to remember, you got to count the move from here to here. That's one of the place values. Now it's up to your, whether your teacher wants you to have a 0 in front of the decimal. I guess that's, we'll call that your choice. And well, there you have it. A little bit of exercise using scientific notation, but really it's all about the place value. So, hey, I'm going to say thank you again for watching Naughty Notes, and pay attention in algebra.